And at the end, you have a food security problem. And you might be wondering what kind of story I am telling to you. Well, I'm telling you the story of the causes of the French Revolution. There was, of course, all its political, societal, public debt background. But the main driver of the French Revolution was an eruption 4 years before the French Revolution in Iceland, in the Laki system, that caused this period of famine, which in turn pushed. I might be telling you the story of a certain drought that, coupled with the decision to transition from family farming to income farming in a certain country, and the decision to go towards income farming and especially cultivate cotton because it is on high demand in the market, without considering that cotton needs a lot of water. Well, this decision that happened recently, coupled with an unprecedented drought in a certain country, made 1.8 million people move from the countryside to the cities. And this was one of the driving pressures of the Syrian revolution. I might go on for a long time. But what I wanted to tell you is that we need to put under control this system and all the sub-balances which are connected. We might do it at different levels of complexity. For instance, we might imagine a matrix that has one case for the Pinatubo volcano that erupts, connected with one case that concerns agricultural productivity in Asia that slows down, connected with one case that concerns Wall Street trends that suffer from it, connected with one case that concerned my auntie Josephine, who had invested everything in Wall Street, loses everything and commits suicide. Unfortunately, we cannot do that because it's too complicated. We don't have the computational power, so we have to use much simpler matrices. And here is one that I present to you. It's just a 4 cases matrix. And it was the one chosen by the international community as the issue of the long reflection started with the Earth Summit in 1992 and concluded with the second Earth Summit. How does it work? It's easy to understand. Imagine an environmental phenomenon like a drought. From the point of view of mankind, it doesn't only stay environmental. It immediately transforms into a development phenomenon, an economic phenomenon, because a drought might imply a failed harvest. So if this happens in a country where there are so-called social and economic safety nets, like the farmers insure their harvests, or the state intervenes to help them, normally the chain of consequences stops there. But if this happens, for instance, in a place where farmers do not insure their harvest, like the Sahel, the chain of consequences can continue when an economic fact determined by an environmental fact transforms into something that concerns human rights. For instance, when the failed harvest makes the difference between sending or not sending your children to school. But take a family, submit them to uncertainty about their subsistence, compression of their fundamental rights, and there you have the recipe of conflict and migrations. To a certain extent, it is obvious, but concerning the role of our audience, it is particularly important to notice that this mechanism works very well because there is an industrial sector that rescues the desperate much more quickly than any other sector. And unfortunately, it is not the Red Cross, it is not the UNHCR, it is criminality. The one economic sector that rescues the desperate quicker than anyone else is criminality. And it takes 2 streams. Very easy to understand. My farm doesn't produce anything more, I still have to give something to eat to my children. I look around, and normally the first way out can be so-called private criminality. Well, someone is offering me a good bunch of money if I swallow some nodules with cocaine and bring them over the boundary. But it is also public criminality. My farm doesn't produce anymore. I look around and I see that in my area there is an employer that pays quite considerable wages. Normally I wouldn't join them, even though the wage is very high, because the kind of life that they propose me is not the one I want. But in this situation I have to join them, and I'm talking about Boko Haram in the Sahel and about the situation around Lake Chad right now. So this is the first theoretical aspect that I would like to underline. There is another one, which is, which is often not understood. You will often hear about climate migrants or environmental migrants. But, well, let me please specify that there are no climate migrants. There are no environmental migrants. Why? Because a migrant is someone who has at least a little bit of freedom in his decision to move from a certain place to another place to make his life better. It means that you can only contemplate migration if you are above a certain level of income. Below that level of income, you are inside what is called the poverty trap. You cannot conceive moving. You cannot even pay those 20 cents to be hanging outside the truck to go from the countryside to the city. Now, what happens is that those who can be migrant, who can conceive migrating, normally have a level of income which is enough also to absorb, at this stage, for instance, a drought. If you are rich enough to conceive, and I'm talking about poor people, but if you're rich enough to conceive a migration, normally you're also rich enough to absorb one drought, one flood, this kind of things. So what happens? When climate change or biodiversity decay strike, normally does not affect those who could be migrating, it affects those who cannot be migrating, and it makes a huge difference because a migrant can be beneficial to himself, to his community of origin, and to the community that receives them. But these people are not migrants, they are forced movements. It means that they go away without any safety net, and again, who rescues them? It's illegality. And that, again, is the central role of security forces all over the world in this phenomenon. What climate is creating is not migrations, it's forced population movements, and this concerns directly armed forces. Because a migrant could be useful. Someone who moves forcibly in desperation is most likely destroying himself and everything around him because he's prey to illegality. One third consideration. You often read on the medias that the problem with climate change and also other forms of environmental degradation, but especially climate change, is severe weather events. You read that there was a flood, so people went around and this kind of. So this is strictly not true. Let's say I cannot treat biodiversity loss, land degradation. I will just talk about climate, but to make a wider point that concerns also the other forms of environmental degradation. Climate change has three kinds of impacts. The first one is on human health and physiology. Heat waves that kill our elderly people, the enlargement of epidemics, aerials, and this kind of things. Then it has a second kind of impact, which is on infrastructures, especially with those severe weather events, you know, the typhoon that destroys houses or bridges and things like that. But nobody talks about the really dramatic impact. And on this, I come back to the first thing that I said. What we are defending, if we defend the environment, is balance. Why? Because if we live in a place called planet Earth, on its very tiny outer layer called the biosphere, and the biosphere, by its nature, would be chaotic. Actually, the planet would be chaotic. It means governed by the butterfly effect. The Fluttering of the wings of a butterfly in Tokyo can be blah, 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 the hurricane in Florida, but it also could mean that the sneezing on the right of an ant in Pakistan could be the first event of a series of events that will destroy the bridge that I've just built. And who would be a bridge builder in a place like that? In other words, if planet Earth was only chaotic, there would be no life. The fundamental chaotic nature of planet Earth is harnessed by something different, which is balance. It is true that it is chaotic, but all this chaos tends to resolve in balanced states, which means what? It means predictable states. It means that nature behaves according to cycles that we can foresee. If we cannot predict the cycles of nature, we cannot organize society. How can you be a farmer if you haven't the slightest idea of when it's going to rain? And it is not only a problem concerning poor populations in rural areas. How can you be the manager of water distribution in New York if you don't have the slightest idea of when the Appalachians will be covered with snow? So, normally you hear about climate change as a threat because it will suppress some resources or it will bring you very high storms or drought. Yes, there is this part, but the real problem is that climate change is an over-intake, a huge over-intake of energy in the atmosphere, the equivalent of the explosion of 400,000 atom bombs per day. And this transforms not really into heat. Heat is relative. Japan has an average temperature which is almost 2 degrees higher than Italy, but is more developed than Italy. So it's not the temperature in itself the threat. The threat is that all this energy makes our system totally unpredictable. And if it's unpredictable, you cannot have agriculture, you cannot have infrastructure, you cannot have economic organization. So we have to pay attention to this. Not only the areas in which some resources are vanishing are concerned. Climate change is destabilizing everything because it's making everything unpredictable. And, well, let me just give you very quickly, and with this I conclude, a hint of what might happen and a hint of what's happening. I'm showing you the band of glaciers of Himalaya, Hindu Kush, and Pamir. These are forecasted to thaw, to crumble down. Beyond a certain level of heat, they will not just keep on thawing, melting gradually in proportion with the heat increase, they will just crumble down. I don't have the time to explain you why. And if you tell this story in Western Europe, maybe at a dinner with people who might finance your programs, they would look at you with a certain concern like, oh, I'm so sorry, the loss of the beauty of the alpine landscape. Maybe they even reason about the impacts on Tibetan culture, and these are very important things. But normally they forget that whenever we lose an element of this fantastic balance, which is the biosphere, we don't only lose its presence and beauty, we also lose the function it performs to maintain the rest of the balance. If we lose the bees, we don't only lose the beautiful buzz, we lose honey making, we lose pollination and things like that. If we lose the glaciers, we lose a lot of things, and especially a service which is essential for us, which is an orderly output of water towards the valleys. Look at this area. There is a tragedy on the north. I don't have time to treat it, but to the south, it's monsonic climate. It means a very wet season alternating with a very dry season. What do the glaciers do? They store excess water from the humid season and release it gradually during the dry season. If the glaciers crumble, it means a tragedy for mountain people, 913 million people who are at immediate risk of migration. But it means a problem also for the valleys, who suddenly find themselves trying to manage an unmanageable alternance of floods and droughts. Now, it has become a commonplace to explain the Second World War not with the personal lunacy of some dictators, but with the socioeconomic stress that some populations, especially in Europe, underwent. Let's take the German population that, under that stress, was pushed into freely electing Hitler to their parliament. We're talking about 20 million people belonging to the German middle class who lost the value of their savings and their jobs. Here we have 450 million forecasted people who might lose their rice, water, roads, in an area in which 4 states, India, China, Pakistan, and Russia, have nuclear bombs. But Houston, we have a problem, but my job is not Nostradamus. We don't have time to treat how to react to this, but we can react to this. So, Europe, our area, is in a convergence zone of the worst forecasted climate change impact, which is the thawing of the Himalaya glaciers. Europe, why Europe? Well, if you're a little bit familiar with the history of this part of the world, you might know that the Roman Empire crumbled at a certain point because it had internal problems, but above all, because of the arrival of some populations that were dubbed the barbarians. But the barbarians at the origin were Central Asian populations who started moving due to a tiny climate fluctuation compared with that. It's far, but it concerns us. It's the butterfly effect. If this is a possible future, we really have to avoid, and I see security forces very much indeed essential in managing all this. Europe is also in front of the first large-scale phenomena of this kind. I'm showing you a map of North Africa, which is mainly composed of deserts that have been deserts for thousands of years. The desert is not a generous ecosystem, but still there are populations that adapted to live there. Except that now we don't only have the desert, we also have an active zone which more or less overlaps the Sahel. This is the area of desertification. This is where we're not missing resources, but where climate cycles became unpredictable. Here people don't know what nature will do. 3 years ago it was in Mali and there was a certain panic among the farmers, but not because there was no water, because it rained before the usual season and it destroyed their investments in seeds. Desertification in this area is not brought by drought. It is caused by the same amount of precipitation as usual, but falling in a shorter period of time. But well, you see where it's placed. You might observe that it overlaps the area of concentration of hunger and conflict, the area of concentration of terrorist dynamics, the area of concentration of illegal trafficking, and well, see where 9 out of 10 of those that we called migrants, which are not migrants, they are forced population movements, come from. I will conclude with this. We don't have time to get into the solution. Where is it happening? In 79 different areas of the world, they all have something in common. It's where a fragile ecosystem overlaps a fragile society. If we go on this way, also non-fragile societies will be concerned. You know, we don't talk a lot about it, but for instance, the very quick thawing of polar ices is already bringing a contemptuous dimension in the Arctic. Russia, in 2007, planted a titanium Russian flag on the North Pole to say, this is mine. And even among very good friends, we start to have some, not fights, but disputes, difference between the United States and Canada for the control over the Northwest Passage. Because the Northwest Passage was a mythical, non-navigable route. Now it's opening up and it's worth $11 billion a year. So is it mine or is it yours? To say nothing of the hydrocarbons up there. But at this stage, it's happening where a fragile ecosystem overlaps a fragile society. The islands, not many people, but they have a very high symbolic value. They're sinking everywhere. The deltas of the rivers. The largest systemic threat in the Mediterranean is a rapid sea level increase, which can salinize coastal plains. Salinizing means that agricultural productivity is dead. We have a problem in our country with a river called the Po. It's important for us, but it's a really small river globally. Well, it can salinize within 20 years the delta of the Nile. It means jeopardizing subsistence of a country that has 120 million people. Then again, something that is symbolic in terms of numbers, but it's still very, very important. It's destroying the cultural and productive references of all the Arctic people, the so-called Inuits that we have to respect. It's happening in the drylands, and we had an example before. But I would like to conclude, and I mentioned it, asking you not to forget the most forgotten of all, which is the mountains. We never think about the mountains. We have the idea that in the mountains you just have a scattered groups of populations not really relevant. Actually, it's 913 million people who are there because they have a special link with the mountain ecosystem. The mountain ecosystem is very exposed to climate change. It is very rapidly decaying. And if people are in the mountains, there is one reason. It's not, if they want to make a production, which is the usual one, they would go to the plains. It's easier. If they're there, it's because they need the mountain ecosystem. Of course, you have in mind the poetical production of traditional quinoa. Yes, there is this part, some fantastic cheeses. But for instance, 20% of the tourist activity on the earth is run in the mountains. It concerns all those that are organizing skiing resorts and things like that. So I think I've gone even over my time. Thank you for listening to me. I hope this was helpful to engage in a productive discussion. I might ask the next speaker either to be contained in 12 minutes, because at 10:30 we have to stop, or maybe he can go for half of his presentation now, and then we continue after the break. Except that I'm not a military, so I'm not prepared. I don't have the list of speakers. Thank you. Elisa.
It's your turn.
Your turn. Just get a note.
Good morning. My name is Susanna Corti, and I'm Director of Research at the CNR, Italian National Council of Research, in the Institute of Atmospheric Sciences and Climate. And I'm here to present something about the results of the last IPCC report of the United Nations on climate change. And in particular, I was involved in, I don't know if I...
Sorry, the name of your presentation?
It's Corti Vicenza. Yeah, yeah. And yes, I'm here to present some of these results. I was involved in the report and as a leading author of Chapter 4, which is the chapter of Future Global Climate Scenario-Based Projection and Near-Term Information. Few numbers about the reports. That was basically, there were 234 authors for different countries, 65 countries. And there was the acceptable balance, not the best one, but you see between women and men. And there were 30% of new authors in IPCC. And actually, we reviewed 40,000 scientific publications. And plus, we had 80,000 review comments. And 46 countries commented on unifiable governance distribution, just to give you some ideas of what was about this United Nations report. And Well, I will start with probably the most important of the statements of the final conclusion of the report, that is recent changes in the climate are widespread, rapid, and intensifying. And they are unprecedented in thousands of years. So we're really basically facing something that has been unprecedented. And I can show you something. Okay. Basically, yeah, okay. You can see in the plot of the left a plot related to the temperatures, the global temperature of our planet, and this is basically, it shows the changes relative to the pre-industrial period, which has been defined as 1850 to 900. So it's not really pre-industrial, let's call it early industrial period. And you can see that the temperature where there's some fluctuations that are reconstructions from proxy data, but in the last basically 150 and 170 years, we had this ramp of climbing of the temperature. And if we magnify this period here, basically one can see that everything happened basically in the last kind of 70 years or so. And if you look at the last decades, so the 2010 to 2020, we have that the global temperature of our planet is about 1.1 degrees warmer with respect to the reference period, which is this one. Okay, and here you can see that the observed warming is driven by emission of human activity, which is, for example, we can see here that this is basically the warming, and here in this plot you can see the causes of the warming. And basically here you have all the warming, what is, I cannot see, sorry. And this is the part which is actually related to the aerosols. So this is human induced, but this is cooling effect. This is the warming without aerosols, and this is the total warming. So, and in here, very, very tiny, almost nothing, you can see what is called natural causes. So basically cycles in the solar or so. So it's indisputable that everything that you can see, unless a few tiny shares, are really due to the human-induced warming. And if you look here, you can see, and this is a quite complex plot, I try to explain it, but because I put it because it's pretty important, and the first time that we had this kind of plots was for the third IPCC report in 2001. And basically, in the line in black, this is the observed temperature between 1850 and 2020. As before, it's the same plot we saw before in the other plot. And they are different, the other lines are, the red lines are the average of all the climate models that have been basically run with a simulation of tens or maybe more than tens, few tens of simulation in which actually the model were forced with both natural and human forcing, radiative forcing, so basically considering the increasing of CO2, etc. And you can see that it's pretty much the simulation, all the simulation, all these bands, they can follow pretty much what happened. On the other hand, if the models, the same model, do not include the human forcing, so basically the increasing of CO2, basically what happened is that at the given point around the 60, these two lines, they separate and we don't see any difference. So this is, in a way, it's important because basically these plots can tell you two main things. The first is that the models are, at least for this global indicator, they are reliable. So we can believe in what they produce. And on the other hand, the second important thing is that if we don't put the anthropogenic forcing in the models, we cannot reproduce actually what happened in the temperature. And this is on this part is also an interesting plot because basically this is the observed change. So what this global temperature, how this global temperature actually impact on the different region of the world. And you can see that everything is more or less orange and red, and these are variation of temperature. And the thing important is that this is how the globe is now. So basically, we have a huge warming in the Arctic region, and basically more warming in the continent. This is the same, but reproduced by the average of all the model. And you can see that the model can do a acceptable job. Well, there are differences. There's some overestimation and underestimation, but overall, these two maps are quite similar. So this is important because actually, then we can see what the model can predict, can project for the future given different scenarios. In any way, what we have seen for the past, that the concentration of CO2 is the highest in the last 2 million years, that the sea level rise is fastest rates in the last 3,000 years, that we have the lowest level of Arctic sea ice in the last 1,000 years. And that's the unprecedented retreat of the glaciers. So this is also related to extreme heat, heavy rainfall, drought, fire weather, ocean acidification. And so basically, the conclusion is that unless there are an immediate, rapid, and large-scale reduction in greenhouse gas emissions, limiting warming to 1.5 will be beyond reach. And actually, probably it is already beyond reach. These are the projection for different scenarios for this century. And basically, we see here that for 1.5 is here, and this is the near-term period, so 2020 to the next 20 years, basically. And you can see that basically all the scenarios are almost there, and the high scenarios are above the thresholds. The same is true for this for low CO2. So if we look at the 2050, actually, you can see that basically, if you want to stay under 2 degrees, we should follow the low and the very low scenarios. And with the intermediate, that is the one that we have been following now, we are already above that. And this is the world. Yeah. Okay. So this is the last slides, and then I have a couple of other ones for after the break, so we can think about that. This is our world at 1.5, at 2, and 4 degrees. And we can see that here what the corresponds. And well, of course, even at 2 degrees, we can see that the warming is very, very high in the Arctic. At 4 degrees, this is well, we cannot think at a word in these circumstances because it's really frightening. Okay, we can reconvene later.
Yeah, thank you. Actually, we had to be very rigid on timing because it's linked with the streaming. Streaming is exactly interrupted at 10:30 and it restarts at 11. Since we lost some time and not to do that thing that we reconvene at 11, but we actually start at 11:15 because we are seating, etc. May I invite everyone to quickly take its coffee and be here maybe 5 minutes before 11 so that we can start at 11 sharp. Also to respect all those that are following us online. Thank you for your patience in splitting the presentation in half, but it was, I think, really the basic one.